Hello everyone. Today I'm going to discuss about Fullerenes. Hello, I'm Dr. Neha Patni. So let us see what is Fullerene. Fullerenes are allotrope of carbon. So there are many similar with that of graphite and diamond being an allotrope of carbon. But there is something different with respect to chemistry of Fullerenes. They are hollow sphere kind of structure. They are ellipsoid. They are having different names. You may call them as buckyball. You may call them as soccer ball. They look like that. Nested cluster Fullerene is also known as bucky onions. So you have different terminologies for Fullerene. Overall, you may call it as a Fullerene. It is similar to that of graphite in its structure, but you have different hexagons and pentagons along with it. So it's having something different in its structure. As I said, Fullerene has been named after Buckminster Fuller, yet it was discovered in 1985 by Carl Croto and Smelly, but it was named after Fuller. And Fuller was basically an architect who actually designed a geodesic dome based on the structure of hexagons and pentagons, and that is how Fuller gave the name to Buckminster Fullerene. As I said, it is having alternate pentagons and hexagons in its structure. So Fullerene is not only related with 60 carbons bonded together in a shape of buckyball, but it has more to do with it. You indeed maybe not knowing it, but we have actually crossed thousands of the carbons in a single molecule. It's not only these 70, and these are the common clusters 70 to 84, but let me show you some of the pics of the Fullerene having more than that of 60 carbons. Now here in the structure, at least 960, I can show you right now. So imagine these many carbons clumped down together in a single molecule, and it looks like a buckyball, a soccer ball. It is basically a hollow kind of structure. So you can imagine the kind of chemistry it is going to have. It is quite interesting. But I am going to stick today for C60 Fullerene only. So let us go in the detail. C60, as I said, is having alternate pentagons and hexagons. Here in the structure, if you see, you can easily locate where is pentagon. Here it is, right? And it is having alternate hexagons. So this is a hexagonal unit. Along with it, there is one more hexagonal unit. And now you can see a chain of hexagons. So earlier you were having pentagon followed by hexagons, and then it is having one more pentagon unit. So this is how it is having alternate pentagons and hexagons. And this is again the same structure which you can see here, pentagons and hexagons. So you can easily locate that it is a hollow kind of sphere which is having alternate pentagons and hexagons in the structure. It's very interesting. One more interesting thing about it is having different colors. Now if you can see here, in solid form, in a crystalline form, it looks like this, but imagine when you dissolve it in a solvent and it becomes liquid, the color is this. Such a pretty solution it is, light pink Fullerene. So that is how it changes color also. There are many methods to prepare Fullerene, like arc vaporization, laser ablation, electron beam evaporation, and there are many. I've just listed main of them, but I'm not going to discuss them in detail. My major focus is just to give you a glimpse of Fullerene. So this is it regarding preparation methods. Now again, to elaborate structure one time more, when I said it's having hollow sphere, when we said it's buckyball, it's soccer ball, you need to give it a terminology, you need to give it a term. So technically speaking, it is basically a truncated icosahedron structure. So you call this structure overall is truncated icosahedron. Obviously, icosahedron is a polygon. So it is going to have some 60 vertices in it, 32 faces, and then 12 pentagons and 20 hexagons. So in all, C60 basically is a polygon, and you may call it as a truncated icosahedron. And now you can see that it's a hollow sphere, so that you may compress it down, you may take it out. So it is aromatic, so it's having resonating structures also. And Going to the hybridization portion, it is having the carbon is hybridized as C, like sp2, and that means the 4 valency of carbon is satisfied by 2 single bonds and 1 double bond. So it's like alternate single and double bond in the structure. So going to the properties of fullerene, the first one, definitely it is an aromatic. So when it is aromatic, obviously it has to follow Huckel's rule. So I hope you remember what was Huckel's rule. It was 4n plus 2 pi electron rule. So it do follow that pattern, and that is how it is aromatic in nature. And that is how it is having resonance also. And regarding the chemistry, the reactions, it's almost similar to that of electrophilic. It is almost stable but not fully unreactive molecule. Solubility is extremely interesting. As I said, it is dissolved in different type of solvents, but it do render different color. Now if you can see here, I've written that if in carbon sulfide, disulfide, it gives you violet color. At the same time, when it is dissolved in benzene, you will have a pretty magenta color. So that is how it it is actually dissolved in solvents at room temperature, and it gives different color. Now coming to the last slide of today's presentation, it is related with application of fullerene, and again there are many applications. I've just simply written few of them. The first one is it is used as a lubricant. I think you can remember the graphite also is used as a solid lubricant. So the way graphite is used, similarly lubricant like fullerene also can be used. Fullerene is an allotrope of carbon. So because of the flexibility in structure, it may also give that flexibility. It's not rigid, it's not tough. So the bond is not going to break if you apply it in between the machine, which is sliding over each other. So you can use it as a lubricant the way you used graphite. You're obviously making by making a DAG. And then it can be used in like as a superconductor, ferromagnetic devices, there and lot many electronic devices it is in use. But there is one more important application, which is medical application. You know that nanotube is having targeted drug delivery application in medicine. The similar way, this also is having that application. Lot many are written here, but medicine also is one of them. So I think that is all for today. What I wanted is just to give a very short glimpse of what is fullerene, so that you may prepare a short note kind of thing on fullerene based on my presentation. So thank you so much, and do subscribe my channel if you really like the videos.